a surgeon taking a test. So we then ask them, what is the probability that someone who is qualified will answer this test question correctly? That is the whole Angoff method. We can also say, to make it easier, because sometimes people don't understand probability very well, so we can say out of 100 qualified people, how many will answer this item correctly? So if it's an easy item, I may give a rating of 0.8. So I'm saying there's an 80% probability that the qualified person will answer the question correctly, or 80 out of 100 will answer it correctly. So if we were a standard setting panel, each of you would individually make that rating for a test question. So you might say, I think this is so easy that 90 out of 100 qualified people will answer correctly. And you may say, no, I think this is difficult and only 50 out of 100 would answer it correctly. And that is okay for you to have different judgments, because we gathered you together based on your different backgrounds. So here is a scale of very unlikely to very likely. And I'm just going to have some water for a second here. So as we see down in the, put this down for a second, down in the very unlikely area, if people have only a 5% probability of answering the item correctly, that means we think it's a very difficult item. If we think that there is an 80% probability of answering correctly, that is either a very easy item for those people because they have all been trained in this. So as an example, if we had a 12th grade test, which in our system is the last grade that students are in, and we gave them the question 40 times 8 equals, would that be easy or hard? It'd be very easy. So my probability as a judge, as a panelist, I might, whoops, there you go. I might give this a 0.95 because I think it's very likely that a student would get that correct. Now, do you think it's reasonable for a rating to ever be 1? And why not? What? Yeah, measurement error. Because even if I know the answer, if you could get into my head and know that I know the answer, I could make a mistake. I could circle the wrong answer. And what's very, I shouldn't say it's amusing because it's not, well, it is amusing, that the judges will do that themselves when they take the test. That's why I tell them, I imply that I'm going to judge their outcomes, because they will say, when they're discussing their ratings, they'll say, I can't believe I got that wrong. I know that answer. And that's what a student will do. They either misread it or they just happen to mark the wrong answer. So when we collect judges' ratings, I usually tell them ahead of time. I give them this same little speech. But then if they give it a 1, I say, do you really think that that's reasonable, that a student, every student in the class, that there is a probability of 1, that if I got every student that's qualified, that none of them would mistakenly mark the wrong answer, and then they admit, no, that's not very likely. Also, how likely is it that, let's say, we had a multiple choice test on plasma physics. And I don't know about you, but I don't know anything about plasma physics. But if we had a multiple choice question, do you think it's really likely that none of us would get it correct? No, by chance, a quarter of us would get it correct. So in general, ratings of probability below 0.25 for a 4-option test and 0.2 for a 5-option test are not that likely. Now, the exception is if you have a question that has the wrong key, or it's got 2 responses that are almost equally correct. If you have a bad test question, you really could have a probability less than chance, because your good students could be pulled by another response. But that's if you have a bad test question, and hopefully you would not have a bad test question. So here, like I said, there's no chance, and here there's certainty, and neither of those extremes are really very likely. If we think there's an even chance of students getting it correct, we would give it a rating of 0.5. So here is an example of if we had a 5-item test, which I hope to God that you would not have because it's too short. But if you did, just for the purposes of example, let's say this is panelist 1, whoops, this is panelist 2, and this is panelist 3. So I ask you, let's say you're 1 and you're 2 and you're 3. Each of you are going to make a rating of this test question independently when we start out. So this person, for item 1, they think the probability is 0.55. For item 2, it's 0.6. For item 3, it's 0.55. For item 4, it's 0.4. And for item 5, this is actually a constructed response item where there are 3 points allotted. So it might be an essay, and a student could get a 1, a 2, or a 3. So they think that the just qualified student would get a 1 on this particular item. Now this panelist has ratings that are, this rating is the same, this one's a little lower, 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 and higher. This panelist, now realistically, I don't think it's very realistic that these would all be so close, but anyway. So this, they say 0.5, 0.5, 0.45, 0.45, and 1. And then each panelist's cut score is merely a sum of their ratings. So this is not rocket science, as we say, to do the Angoff method, because you ask for ratings and then you sum them together, because the best way to estimate a cut score is to say someone who is just qualified, how would they do on the test? So you sum these ratings and then you average the ratings across the panelists. So for these panelists, there was a 3.1, a 3, and a 2.9, and when we average them, we get a 3. So that is the basics of the Angoff method. Pretty simple, right? Now, what we do is we don't stop there. We don't just collect ratings and stop there, because even in a jury trial, going back to what I was talking about before, usually when they go in, they take a vote right away, guilty, not guilty. But they don't stop there. They discuss the evidence, they argue with each other, they might call the judge and say, could you explain something a little better? So there's a whole process for reviewing the evidence and getting feedback from the other members of the jury. And the same thing happens in standard setting, generally. I mean, there might be some people who don't do this, but we generally want to share with the other panelists what other people said, because they will learn from that. Like I said, I may have gotten the answer wrong by mistake. I may not have noticed that this question really requires more knowledge than I thought, because I'm an expert and I just knew it, but then someone may say, do you realize that the student had to carry the, when they were multiplying, they had to carry something to the next? Oh yes, I didn't realize that. And I didn't realize that an easy mistake would be to not carry that number. Okay, I actually think that it's a little harder than I thought. So my probability, I'm going to revise from 0.8 down to 0.7. So we have this process so that people learn from each other and they see how other people rate them. And they don't have to revise their ratings, but they often do because they learn from the other people talking. Or if I'm from a wealthy school district, people may say, well, actually students could make this common mistake. And I might say, oh, you're right, yeah, okay. Or they may not change their mind, but it's often they do. It's very interesting to watch how people learn from each other during this process. So in this sample feedback, if we had 15 panelists, we might give them this feedback that shows them how their ratings are distributed. So here, the majority of people all are giving it a rating above 0.7. And 2 people are giving it a rating between 0.4 and 0.6. So the panel average is 0.85. And then we often tell them how the average student did on the question. Because it's often very surprising to people. They'll say, oh, this is so easy. And then they look at students how they actually did, and they'll say, wow, this really was harder, and why is that? And then they discuss it and say, oh, I didn't realize that students could be misled by this distractor, because it is very plausible. So it's not to tell, often they say, why did you give us this information if it's supposed to be our judgments? But it's more about relative difficulty of questions. It's not about the exact value. It's about, wow, this question, if we on these 3 items, this is really more difficult than these other 2. And it prompts them to look at it and say, what could it be that's making this so difficult? So it's just a stimulus to get them to think more about their ratings. Now these cells are shaded because look at this, panelists are really spread across these ratings. If we had a lot of time when we do our sessions, we could discuss every item, but often we don't have enough time, we don't have enough money to do that. So we want to focus on the items that have ratings that are very discrepant. Okay, so we often have a software, in Excel, we have formulas set up to show us which items have ratings that are most discrepant, and we will focus on those just to get the conversation going. Now, as I implied before, we have our panel, and the panelists, we come out with our average Angoff rating. We sum up every panelist, then we average across that. And that is a recommendation to the decision makers. We make that very clear to the panelists that this is a recommendation, because the decision makers take that recommendation and may decide to adjust it. They may say, well, going back to those errors of classification, they may say, I would rather not be very harsh because this is a new test and people are just getting used to it. And I would rather lower the cut score a little bit. And this is not, you can argue, about the wisdom of that, but this is reality, that the decision maker has the final say. And it's very important for the panelists to know that, so that they don't say, why did you not pay attention to what we said? It's because there are policy reasons and other reasons that decision makers may adjust the cut score. So it's just important to realize that this is one source of information that goes into the decision. Whoops. Okay. Now, the bookmark method. Has anyone heard of the bookmark method? Okay. The bookmark method is very often used in the United States for educational tests. It's not used generally for licensing tests, but for educational tests, it's often used. Okay, let's see. The reason it's called a bookmark method, let me see here, is that literally what we have in the bookmark method is we determine how difficult the items are, generally with item response theory. You can do it with classical test theory, but it's most often done with item response theory. So we order the items by difficulty, by their B parameter, for those of you who know item response theory. And we ask the panelists put a bookmark, a literal bookmark, and we're talking about like a sticky flag, where you think the student will stop knowing the answers at a 67% probability. So it's, instead of every panelist giving if you had 100 item tests in the Angoff method, you would have 100 ratings, right? If you had 2 cut scores, you'd have 200 ratings for Angoff. But with bookmark, you have just 1 rating for each performance level. So I wish I had a book, but I don't have a book. Oh, here's a book. Okay. I'm going to take this book, and I'm the panelist, and I have looked through all of these items. Okay, about here, this is where my student goes from having a more than 2/3 chance of answering correctly to a less than 2/3 chance. And this is my bookmark. So I literally put a sticky note here to say, this is where my just qualified student starts to have a less than 2/3 probability. And then this on the IRT scale has a location, and that is what my cut score is. And then we generally take the median of all the panelists' cut scores. So I think you can see the appeal of this, because they're making 1 rating instead of 100, and it usually takes less time. And sometimes teachers who are doing these reviews find it easier to look at items that are already ordered by difficulty and pick the cut score. Now, some people are looking puzzled. Does that make sense? Okay. All right. Again, the decision makers set the final cut score, but in our meetings, we would still have the rounds of discussion and the feedback that I discussed before, but it would be more about, they would not do it item by item because we didn't do item ratings. We would do it on the cut score itself. So I would show a distribution of all of your cut scores, and you would say, oh, you put it down there, I put it up here. Let's look at these items in between and see why you think there would be a high probability of a just qualified student getting this correct, and I think there would be a lower one. Now, the bookmark method did not have a lot of research behind it in the early years, and still doesn't have a lot of research. And some of the research that has come out has not been very confidence building. I'll just tell you that I was a discussant on a paper where by mistake they had two panels, parallel panels, and by mistake they randomly ordered the items in the booklet, and they came out with the same cut score as the other one. So I'm just telling you, we use this method when our clients want us to, but I personally have some misgivings about it. But that's just my personal opinion. Okay. Oh, here's our little bookmarky thing. So this is, again, where, I don't know why that's doing that. Yes. It's splitting it into likely to know and likely not to know. Okay. Now, those two methods are looking at the items and making a decision about the items and how the just qualified student would do on those items. There are also methods where you look at work products. So you're not just looking at the item, you're looking at what the students actually produced in relation to the item. And these methods are used primarily for constructed response questions like essays, because it would not be that much fun to just look at 1, 2, A, B, C, A, B, A. I mean, that's not gonna, I think people would shoot themselves. They had to do that for long. But when you have an essay, you could get a pile of essays and say, this does represent proficient work, this one doesn't. And that is a task that teachers find very comfortable because that's what they do in their classroom. So they actually look at the work product and make a judgment about whether that student is qualified or not. So again, they would take the test and do the define what qualified, but then they would look at samples of the products without knowing the scores. That's the key. If they knew the scores, it wouldn't be as effective. So what they do is they look at the product and they say, you know, qualified, not qualified, and they go through a lot of samples and make those ratings, like I said. And then we know the actual scores, and so we use the actual scores to analytically determine what the cut score is. Okay. We can also do this method. I'm just going to look at what time it is. 2:30. Okay. We can use this method with people. Now, what that means is I need to have, if I'm a panelist, I need to have people that I actually know. So it could be my students. So let's pretend you're all my students. I'm going to say qualified, not qualified, qualified, not qualified, not qualified, qualified. I'm going to rate you based on my knowledge of you. And then we're going to look at how you did on the test, and we're going to analytically determine where the cut score should be. So, do you see any issues with this method? Well, that's a good point. But what we're going to do, what you would do, is use the ratings for that group of people and use it for all the people that you don't even know. But as a teacher, do you see that there might be some bias when I say qualified, not qualified? I may like you, you're very nice, you're a teacher's pet, you always clean the blackboard. Well, there's no blackboards anymore, but you clean the whiteboard. Or, you're, I know you, so I'm not going to point at you. You are, kind of cranky, and, you might be very smart, but you get on my nerves, and so, So there are halo effects that might influence my judgment. And it's hard to get people together. It's hard to get, I don't want to just go to the most wealthy school district and get ratings of all those students. I want to go to the poor place. I want to go to the minority district. So it's really difficult to implement this because we have to get ratings of all these different types of students and then get all those ratings gathered. So one of my colleagues thinks this is the best thing since sliced bread. I don't know if you have that expression in your country, but he really likes it. But it's kind of difficult to implement. But if you can do it, some people think that it is a very good method. So, okay. So here's an example of scores. And again, when you make your ratings, you don't know the scores, but then we look at it afterwards, and oops, this isn't working. All right, whatever. We have at the top people with a perfect score, and probably not surprisingly, I thought that all the people that I rated as qualified all the people who got a perfect score, I rated as qualified. And then as we go down, it shows the proportion of people, the distribution of how the people did on the test. And you could decide to put your cut score here, because here there was an even split between the qualifieds and the not qualifieds. So there's that. Or I could decide that I wanted to be a little more sure of my judgment, so I wanted to make it where 2/3 of the people were qualified and 1/3 were not qualified. And here is just a graphic depiction of what we just had. This is the percentage of